speaker is Lisbeth Roy, who is the founder of Doctor's Studio, a unique functional, regenerative, and aesthetic medical practice offering advanced technologies including non-surgical techniques using platelet-rich plasma, PRP. Dr. Roy is also the founder and chief medical officer of Studio PRP, a turnkey training and business solution designed for physicians and clinicians to successfully implement innovative regenerative medical therapies and techniques using platelet-rich plasma therapy and treatments. So I'd like to welcome Dr. Roy. Oh, come on up.
Thank you very much. Yeah. Thank you very much. Thank you for the opportunity to present this information to you and to share my experience with you. The talk is about platelet-rich plasma, and I call it PRP 101 because I really want to take you back to the basics and understanding platelet-rich plasma, what it does, what it doesn't do, what the mechanism of action is. So by the end of this talk, I hope to clearly define platelet-rich plasma for you, identify the regenerative mechanism of action. Everyone's always interested in that. And to also review the desired cellular components of platelet-rich plasma. I want you to have a very good understanding of platelet-rich plasma, what cellular components are going to be necessary for the application that you desire. And we will also talk a bit about PRP current clinical applications and future applications. As it was said, I am Dr. Lisbeth Roy. Doctor's Studio is my functional regenerative medical practice in Boca Raton, Florida. Studio PRP is a training, marketing, and research company of which I'm the co-founder, and then PRP Science is a equipment and device distribution company that supplies the equipment necessary to do the procedures or the techniques that I teach. Oh, let me just bring attention. I have a new book called Regenerating Sexual Potential, really a guidebook for all the many ways, including platelet-rich plasma, for restoring one's sexual function. So PRP 101, let's just start by defining regenerative medicine. This is an exciting, relatively new science-based and interdisciplinary approach to healing that involves the body's own stem cells and growth factors to repair and restore healthy function of the tissues and physiological systems. And that's an interesting little and. I'll share a pearl with you later on in the talk. But this is some powerful stuff. PRP was initially developed in 1970. In 87, it was first used in open heart surgery. In 1990, there were many publications, 95, even more that were focused on bone healing indication. In 99, several companies developed tabletop point-of-care systems, and that really expanded the use of platelet-rich plasma. We had intraoperative applications in grafting procedures, in maxillofacial and plastic reconstruction, and also chronic wound use, orthopedics, and the stated open heart surgery example. In 2005, we have even more publications. In 2006, we're using platelet-rich plasma for sports medicine and pain management. In 2007, the first scientific book was written. 2009, we're doing facial rejuvenation. 2015, we have even more publications, and so on and so forth. This is really building some significant momentum. In the 1987 use of platelet-rich plasma for open heart surgery, there was a real welcome surprise. So in addition to the added clotting benefits, they also found that the patients needed fewer transfusions, they needed less pain medication, healing occurred more quickly, and really there was less suffering and a facilitated healing. And that was quite a surprise. Earlier studies also showed non-healing wounds would heal remarkably in 10 weeks post-PRP therapy. That's a big deal, and from there, PRP really exploded across many medical specialties. PRP initially gained consumer popularity as a promise to an alternative to orthopedic surgery. Very few contraindications utilizing platelet-rich plasma. There have been countless studies showing the effectiveness of platelet-rich plasma, where healing and cellular regeneration are the treatment goals. And that's really the key. The treatment goal is healing and cell regeneration. PRP has been shown clearly in the literature to do that. Many medical thought leaders, people using platelet-rich plasma today, have a strong feeling that we need to develop some standards, not only to protect the consumer, but also to more clearly report the efficacy of platelet-rich plasma. And I'll go into that in just a little bit. So let's look at the science, and I'm going to take you right back to the beginning. What is blood plasma? Well, the blood plasma holds the cells in a liquid suspension. It makes up about 55% of the total blood volume. There are three types of blood cells: the red blood cells, white blood cells, and platelets. Platelets are cytoplastic fragments of the megakaryocytes, which are formed in the bone marrow and circulate in the blood. They contain alpha granules, which are tiny encapsulated units. These alpha granules contain the growth factors, 7 actual fundamental growth factors, as well as biologic proteins. And these growth factors and biologic proteins play a primary role in hemostasis, or homeostasis rather, or tissue healing. Okay, so that's, again, well established. Platelets are typically first responders. They are responsible for forming the hemostatic plug and also releasing growth factors into the area. Neutrophils are granulocytes. It's very important as we continue this discussion. These granulocytes are pro-inflammatory, and they are early responders as well. They are going after invading microorganisms, particularly bacteria, very necessary in the inflammatory process. Macrophages are phagocytes, and they develop from monocytes. Monocytes are white blood cells that are anti-inflammatory. So we have neutrophils are granulocytes, macrophages are derived from monocytes, which are anti-inflammatory. We also have fibroblasts, which are responsible for creating an extracellular matrix. These fibroblasts migrate to the area of damage or the wound site as a result of cytokine secretion from the macrophages. We have B cells, lymphocytes, and T lymphocytes as well, and mast cells. Mast cells are also granulocytes, which are pro-inflammatory. Okay, so just a little basic science there. This graph shows the different cell types and how they contribute to the healing and regeneration of tissue. They act in a predicted timeline. You see platelets in very early, followed by neutrophils. Macrophages stick around for quite a long time. Fibroblasts create that extracellular matrix, that scaffolding upon which the regeneration occurs. And we eventually get tissue regeneration. So platelet-rich plasma is really defined by the cellular components. Healthy blood contains between 100,000 and 250,000 platelets per microliter. The working definition, as defined by Marks and colleagues in 2001, is that there is a concentration of platelets such that there is a 1 million platelets per microliter in 5 mLs of plasma. Okay, and that typically represents 4 to 6 times baseline concentration above the circulating whole blood. Okay, and that was defined in 2001. So that's been consistent throughout. Many commercial systems that are available today that create platelet-rich plasma don't actually meet this definition. Okay, so we have grown up through the last many years using platelet-rich plasma. It's quite exciting what's happening now. There's a lot of literature which we'll review here that's bringing light to the fact that these details matter when it comes to appropriate application and desired regeneration. Okay, and that's why I'm taking you right back to the basics. If you're currently using platelet-rich plasma, you need to really understand what type of platelet-rich plasma are you providing this process, and is it potentially effective for that indication? And if you go to this basic science, there's quite a bit of clear evidence that helps us to define that. Okay? I've been using platelet-rich plasma, just to bring it back a little bit, in my practice for the last 6 years as part of a very comprehensive strategy to solve many of my patients' problems. And it's been quite an interesting experience, really, quite an interesting adventure. There are also many, once these platelets, degranulate, there are growth factors, adhesive proteins, we mentioned fibrogen and other bioactive proteins that then develop into a platelet-rich containing gel. And this is many of the growth factors, or the 7 fundamental growth factors that are participating in this regeneration. And you can see it's not hard to understand why it is we're so excited about platelet-rich plasma. When you have the platelet-derived growth factor that stimulates collagen and blood vessel repair, as well as blood vessel generation. You have VEGF that stimulates an angiogenesis and supports wound healing. We have transforming B growth factor, where there's a neogenesis of endothelial cells. I mean, think about the implications of being able to focus this technology to the treatment area. So there's an awful lot that we do know about platelets and the growth factor activity. So growth factors act as chemical messages. They exert a bioregulatory action no matter where you place them. And that gets fun. There's cytokines that participate in this regeneration and downregulate the degenerative inflammation, which in many cases is necessary. You can see we get a repair and regeneration of tissue. We resolve inflammation. You can use platelet-rich plasma for antibacterial and antifungal properties. With the right concentration of platelets, we actually have a migration of mesenchymal stem cells to the area. And, we're stimulating a neuroangiogenesis as well. I really like this definition of platelet-rich plasma. Beyond this 4 to 6 times baseline concentration and 1 million platelets per microliter, it's very important that you understand that PRP is a tissue graft incorporating autologous growth factors and autologous undifferentiated cells in a cellular matrix, where its design depends on the receptor site and the tissue of regeneration. You're saying, what the heck does that mean? What it means is, no matter where you put this platelet-rich plasma, no matter where you deliver these growth factors, you're going to stimulate unipotent stem cells, and you're going to regenerate that tissue. Okay, so if you place it in the knee, you'll have a regeneration of the collagen. If you're using it for bone grafting, you will have a regeneration of the bone. So when degranulation occurs, remember we have these alpha granules contained in the platelets. There's a degranulation that's necessary. We get the secretion of the growth factors. They bind to a transmembrane receptor on the target cell. There is an intracellular signal, a tyrosine kinase receptor signal, that then stimulates this gene sequence, cell proliferation, and leading to tissue regeneration. Okay? So, we think, this platelet-rich plasma, for a while we're thinking this is just a fad. Does it work? Doesn't it work? Well, if you go to the basic science, you can see where it should work. And it's just a matter of teasing out the details, and as we go through this literature and as we have more experience with platelet-rich plasma, we're realizing how to focus this technology appropriately to get the result that we're looking for. It's important to note that these growth factors, once they're activated, they have half-lives starting at 10 minutes. About 95% of them are actually secreted within 1 hour. So these pre-synthesized growth factors, they start immediately working once they're activated, and 95% of them have been secreted within that first hour. So it's important to understand that when preparing platelet-rich plasma, you want to make sure that you have not prematurely activated those platelets. If you've done that, then you've had degranulation occur in your syringe, or maybe in the tube that's in the centrifuge. all right, and you're not going to deliver then those growth factors to that treatment area. This is just a schematic that shows growth factors attaching to the transmembrane receptor, the signaling that occurs in transcription leading to tissue regeneration. So Rugetti and her colleagues studied the relationship between the concentration of platelets and the functional activity changes in the endothelial cell, as well as a stimulation of an angiogenesis. And what she found was there was a peak proliferation of the endothelial cells at 1.25 million platelets per microliter, and you also had maximum angiogenesis at 1.5 million platelets per microliter. So if you're trying to stimulate an angiogenesis, if you're trying to improve or change endothelial function, then it's absolutely essential that you have the right number of platelets in your platelet-rich plasma suspension. She also found that there is, it's on the next slide, here we go, there is an optimal concentration of platelets. So, you know, we humans, we think, well, if a little is good, then more is better. In this particular case, it's not true. With a concentration of platelets beyond that 4 to 5 baseline, or actually 3 million platelets per microliter, we find diminishing returns with regard to angiogenesis. So I'm sharing all of these details with you because I really want you to think critically as you introduce platelet-rich plasma to your patients and as you start using this technology. I want you to think about what is it that I'm trying to achieve and what does the scientific literature tell me I need in order to achieve that goal? Because it's going to be different. And we're learning more and more about those specifics. PRP can also produce a migration of mesenchymal stem cells to the site of injury or the treatment site in this particular case. You can see on this electron microscopy the scaffolding that the fibroblasts have created work to help attract the mesenchymal stem cells to the area and upon which the regeneration occurs. Now again, the devil is really in the details here. If we look at this graph, which Hainsworth and colleagues developed in 2002, you know, not real new science. It's been around for a while. We see that, well, our best chemotaxis occurs at 10 times concentration. So if we want to draw mesenchymal stem cells to the treatment area, then we want 10 times concentration. But remember, if we want to create an angiogenesis, which we typically do no matter where we're applying this platelet-rich plasma, we don't want to be beyond 3 million platelets per microliter. So the sweet spot appears to be that 4 to 6 times baseline concentration, and in this graph, 5 times concentration. It provides us with the perfect storm, if you will. Provides us with significant chemotaxis and mesenchymal stem cell attraction, as well as angiogenesis. So the other thing you have to consider is, okay, I've got the right concentration of platelets, I'm going to create some angiogenesis, I'm going to bring some mesenchymal stem cells to the area. Well, what about degranulation? If you don't degranulate, if degranulation doesn't occur, then you just have a bunch of intact platelets in the area, and you don't have the growth factors that you really desire. So in 2015, there was a study that showed that, in fact, there are different things, in this particular case, NSAIDs, that inhibit degranulation. So again, your perfect protocol is going to set your patient up for the best outcome. You're going to make sure that you're yielding all the right cellular components and that you're preparing that patient in such a way that you will get maximum regenerative potential because you're going to get a thorough degranulation. You're going to make sure that you're not prematurely activating these platelets and that you have full degranulation at the site of injection. This is just a schematic that shows the migration, the setup of the extracellular matrix, the cell proliferation that occurs, and differentiation leading to tissue regeneration. I kind of like looking at it this way. So what's the controversy? Well, you know, if we look at the orthopedic literature, this was presented in 2014 at the Toby conference. You know, half the studies show a positive result, half the studies don't show any change at all. So what about this platelet-rich plasma? It works, it doesn't work. What this study or what this presentation has really brought to light was the fact that not all PRP is created equal. There are many varying cocktails, if you will. Low leukocyte, no leukocyte, white blood cells, no white blood cells, platelet concentrations, some spin low, some are almost super concentrating. So, you really have to think about, what am I trying to accomplish here? And what do I need in order to get that job done? This is a complete biocellular cocktail. We have neurotransmitters in there. We have interleukins in addition to our growth factors. There's many, many devices on the market as well. And so how do you decide? Well, we need to first, and the orthopedics, I give them, orthopedic surgeons, give them a lot of credit. They really are calling for a classification system. If we're going to do studies and we're going to be able to effectively communicate our findings, then we have to include standard type nomenclature for what it is that we're talking about. Again, not all PRP is considered equal. So what works? What doesn't? Low leukocyte, no leukocyte, what platelet concentration? So if we look a little bit deeper, again into that orthopedic literature, we can see that the leukocyte rich, and that is right there, the second to last study, was less effective than the leukocyte poor platelet-rich plasma. All right, so as they looked at this deeper, they really started to see some consistency in the outcomes. It clearly shows that this was an osteoarthritis study, that the leukocyte poor PRP had a better regenerative effect. Okay, so there's a lot to consider. The leukocyte concentration rate, the different formula and composition of the cellular components of your platelet-rich plasma are all very, very important. And when we think about regenerating the tissue, we want to maximize this anabolic effect, the scaffold effect, and the anti-inflammatory effect. We can see with the Yoshida and Murray study that they showed a clear anabolic effect when you had very low granulocytes, neutrophils are granulocytes, and very high monocytes. So that is a very important study. In order to maximize this anabolic effect, we need to have the right growth factors delivered to the treatment site. We need to have fibrogen and this extracellular matrix developed. We need to have the mesenchymal stem cells recruited to the area. We need the monocytes providing an anti-inflammatory effect. And it's important. So the way that you're preparing your platelet-rich plasma is very much dependent upon what your treatment goals are. I like a system that is flexible, right? Because there are times when, if I am a vascular surgeon, a cardiovascular surgeon, and I'm using platelet-rich plasma when I close to prevent complications of infection and to facilitate healing, I'm likely going to want a high granulocyte-rich platelet-rich plasma. I'm going to want my platelet concentrations to be ideal, but I'm also going to want to include those granulocytes. For the procedures that I do in my clinic, I don't want those inflammatory granulocytes. I actually want an ideal platelet-rich plasma that has very low granulocytes, very high monocytes, and very significant regenerative potential. So you can see the literature is starting to bring attention to this fact that not all platelet-rich plasma is created equal. So let's just take you through a basic exercise. I'm surprised by the number of providers that I encounter that don't really understand even the system that they're using. Maybe they've been using platelet-rich plasma for a while. They're not sure of the concentration. They know what they read. They know what they were told by the manufacturer, by their colleagues, but they don't really understand. So I'm just going to take you through some simple math. If you're currently using platelet-rich plasma, or you're looking at a system, think about concentration. We know that we want 4 to 6 times baseline concentration, and we can very easily figure out the theoretic concentration of our system by dividing the whole blood that you draw divided by the platelet-rich plasma yield. So for instance, if I draw 30 mLs of whole blood from my patient, and my system creates 15 mLs of platelet-rich plasma, if I were to yield 100% of those platelets, I would never be able to have more than 2 times baseline concentration. Now, when I factor in the actual platelet yield, some of the best systems yield 80%, the average yield is 60%. So if I say 30 divided by 15 equals 2 times 8, there you have it. 1.6 concentration is the absolute max that my PRP contains with that particular system. And you can see multiple examples of that. So that's the first thing that you can do in your head while you're sitting here. I draw 10 cc's of patient from my blood from my patient. I get 5 cc's of platelet-rich plasma. I factor in my yield. I'm at 1.6 times baseline. So am I actually stimulating angiogenesis? Well, not according to Rugetti and her colleagues. It starts at that 1.5 million platelets per microliter, and it's just impossible to have that at the 1.6 times baseline. That doesn't mean that that solution isn't helpful. It's loaded with biological proteins, and there's still active platelets in there. It just doesn't create that angiogenesis that I'm looking for in my application. So the ideal device would be flexible to the patient and the disease or indication that you're intending it. And you need to consider all of the different cellular components when you're injecting platelet-rich plasma. And again, there's plenty of literature. Before I came to my talk, I just queried PubMed. I put in platelet-rich plasma. There are 8,780 published articles that you can get in PubMed about platelet-rich plasma. So there is no lack of basic science. Some providers will spin platelet-rich plasma in regular yellow top tubes. This is not a good idea, actually, because these yellow top tubes are not completely free, potentially, of pyrogens rather. They may be sterile, but they may be contaminated with pyrogens, and that's bad news if you inject that back into the patient. They're really supposed to be used to collect blood for testing, not for re-injecting with patients. But if you do this, you can create a buffy coat. But remember now, when I'm creating that buffy coat, that contains my platelets, but it also contains my granulocytes and monocytes. So I'm not able to differentiate those. And I'm also going to struggle with yielding high platelet yield because I don't have any barrier separating the blood from the buffy coat and the platelet suspension. That's not really a great way of creating a plasma suspension. You have several single spin systems that are out there, again, smaller volumes of blood. But think about this. If I need to yield a high number of platelets, I need to draw some blood. So though it might be more convenient to draw a small amount of blood, and if you only need a small amount of platelet-rich plasma, then that might be perfect for your application. But you have to really consider that. In these single spin systems, when the instructions or when the marketing material is saying we can yield 4 to 6 times baseline because we know that that's the sweet spot for regeneration, you have to look a little bit deeper. And what that means is if you draw 10 cc's of whole blood, you spin this and typically separate out all the white blood cells, including the monocytes and the granulocytes and red blood cells, you can harvest 2 cc's of platelet-rich plasma from 10 cc's of blood. If, again, our math, 10 divided by 2 is 5 times the 80% or 0.8 platelet yield, is going to get you 2 times baseline, 4 times baseline concentration. So it's possible, but you're going to, if you draw a low volume of whole blood, you're going to have a very low volume of platelet-rich plasma. You might have a low concentration platelet suspension. You draw 10, you get 5, you draw 22, you get 11. Okay, that's platelet suspension. And it might even be effective for your application. But it doesn't meet the scientific definition of platelet-rich plasma, and it will not create a chemotaxis and migration of mesenchymal stem cells, and it will not stimulate an angiogenesis. Okay? So just understand what your treatment goals are, what it is that you're using. This is off a website for a single spin system, and it's a little tricky. Again, you have to think about this. We're looking at a claim that there is an increase in platelet concentration of 2.5 times baseline. Well, if we look to the left of that page, we see that we're creating 6 mLs of PRP from 11 mLs of whole blood. Well, I've already explained to you how that is physically impossible. Okay? If you delve a little bit deeper in the instructions of this system, it's going to recommend that after you spin and you drive the platelets to the bottom of the plasma suspension, that you remove some of the platelet poor plasma. So you're going to be left with a very low volume of platelet-rich plasma. Okay, so it's possible to get a 2.5 times baseline from this system, but there's some manipulation that's necessary. So just understand that. Here's another system, 10 cc's of blood, 5 cc's of platelet-rich plasma. There's an 80, or a platelet suspension rather. There's an 80% platelet yield with this system, so it's 1.6 times concentration. And so there's truth. There is truth there, and I appreciate that. This is another single spin system, and you can see that it creates a buffy coat. So you have your monocytes, your platelets, and your granulocytes in that buffy coat. There's a good amount of red blood cells as well. And if you're needing that in your PRP, this would be a great system for you. You take off some of this platelet poor plasma so that you're concentrating the resuspension of that buffy coat in a smaller volume. This is another system where there's some flexibility with regard to platelet concentration, but there is no flexibility with monocyte and granulocyte manipulation. This is a system that's actually quite flexible. You can spin either a platelet-rich plasma, again, the definition that I use when I say that is 4 to 6 times baseline concentration, with high monocyte, low granulocyte, or you can spin in a different spin protocol to get a high granulocyte count and high monocyte as well. So it depends what it is that you're using this for. I like a flexible system. As the science changes, you need to be willing to change too. You need to be willing to, if you have a system, I have purchased and used at least 10 PRP systems in my practice, and I do that because my focus is my patient outcome. My goal is getting my patient the absolute best results. So I'm using this technology as part of a comprehensive strategy. I want to follow the science so that I understand how best to achieve that goal. So I am very, very quick to remove a particular system from my practice if it no longer meets my needs. I like the fact that there are some flexible systems out there, so you don't necessarily have to purchase new equipment, but you're able to then change as the science develops. And a lot of the science that I'm talking about is just in the last year. So we still don't know a lot. So if we look at the qualitative and quantitative differences of these systems, you will then decide what the right platelet-rich plasma is for you. Some companies have gone through the process of having independent evaluations of their systems and also compared to some of their competitors. Dr. Mandel from Harvard Medical School does a lot of these studies, and you can see that this study shows differences in platelet concentration, differences in the yield, differences in granulocyte and monocyte yield as well. This is another one. Again, Dr. Mandel did 3 different systems. Quite interesting. If we do the math with these 2 systems, and we say we're going to draw 10 cc's or 11 or 22 cc's of blood, and we get about 1.6 times baseline concentration, just doing the theoretical math as I've taken you through, that sounds good. But in reality, there's a lot more that goes into this. These platelets are sticky. And in this particular case, Dr. Mandel showed very clearly that not only was this not meeting the definition of platelet-rich plasma, but you actually lost platelets in the processing. It had less platelets than baseline. So what you have here is a suspension of platelets in biological proteins that might be good for what it is you're using it for, but it's not platelet-rich plasma. So there's no doubt that the basic science and in vitro studies actually substantiate this regenerative healing potential. There is a lack, however, of robust trials and in vivo studies that show, there's a lack of them in general, and then sometimes they show conflicting results, as we saw in the orthopedic literature. We do have several studies in process, and it is quite an exciting time. We are finding that potentially we want different platelet-rich plasma solutions or cocktails based upon the different tissue types that we're trying to regenerate. So I encourage you to embrace this science and be part of not only the solution, but collaborating so that we can quickly figure out, what's the best approach here. There's some real opportunity. So the application. Many of you have heard about your colleagues using platelet-rich plasma for facial rejuvenation, regrowing hair. We're using it in conjunction with our lasers and aesthetics. We use it for sexual, in sexual medicine to restore sexual potential in both men and women. We're using it for urinary incontinence, muscle and joint pain, different inflammatory processes. These are a couple of my colleagues, Dr. Bano and Dr. Perito, who are very well-respected urologists who are excited about this technology after introducing it to their patients and using it in their practice. Both Dr. Perito and Dr. Bano are using platelet-rich plasma before penile implant, so as a strategy to restore sexual function, and also intraoperatively. And that's pretty interesting. Their urology colleagues are quite interested in what it is that they're finding. Dr. Bano presented a poster at the SMSNA Urology, Sexual Medicine Urology Conference last month in Phoenix. It's quite well received. Dr. Bano and Dr. Perito are getting great results for treating Peyronie's disease. Dr. Virag has talked about this internationally. So it's pretty exciting what some of our colleagues are doing with PRP. Dr. Goldstein actually published a small study on the effects of platelet-rich plasma on lichen sclerosis, showed just tremendous potential and real significant benefit. So there's a larger study now in process. It's pretty exciting. Some of our plastic surgeon and hair restoration colleagues are using platelet-rich plasma in hair transplants, as well as just a clinical treatment for stimulating the follicles to regrow a better quality of hair and to come out of a dormancy. We're using this as an intraoperative step in surgery. I know plastic surgeons and cardiovascular surgeons that wouldn't consider doing a surgery without platelet-rich plasma anymore. It's really changed the game for them. Our orthopedic friends have certainly embraced platelet-rich plasma, and I think that they're making some significant strides in understanding what's right for them. The ophthalmologists are using platelet-rich plasma to treat dry eye. That is showing some really great results. And you just can see that there's all kinds of therapeutic directions that we are taking this platelet-rich plasma. And there's no lack of scientific information to actually read and to help you understand. This is the poster that Dr. Bano presented last month. This is a small study that I was part of for sexual dysfunction for women. And so, really, the bottom line is platelet-rich plasma is here to stay. It truly is. We are finding new ways of using it and really teasing out all of the details and what's necessary for regenerative goals, if you will. I'll share with you that little tidbit that I promised. So early on in my experience with PRP, I had a gentleman with significant cardiometabolic dysfunction who had erectile dysfunction present to my practice or to me in a consultation, and he asked, "Can this PRP help me?" I was using the PDE5 inhibitors, Viagra, Cialis, Levitra successfully, and they no longer work for me. And I thought, oh boy, I don't know. I don't know if this is going to work. Let's give it a try. I've had some pretty good results so far. At our 6-week follow-up, he was so excited because his PD5 inhibitors worked again. So we truly got an improvement in endothelial function. We truly restored a physiologic system. And that was very, very exciting for me. That's where the title of my book, Regenerating Sexual Potential, really was born. The light bulb just went off, and it was very exciting. So this is not a magic wand. However, it is a very interesting tool that you can use as part of a comprehensive strategy to solve many of your patients' challenges and problems. If you have any questions, I'm certainly going to be around. My team will be around at the Studio PRP booth. I'm happy to answer any questions for you. I hope that we do collaborate in the future and we really learn as much as we can so we can get the best outcomes possible. And thank you again for the opportunity. I really appreciate it.